Maybe you've heard or read about these, or perhaps you've heard or seen words like these. This course is about all of these and then some. Welcome to Analytics and Predictive Modeling. My name is Dr. Jeff Nicely of the Institute for Quantitative Biology at East Tennessee State University. This is a course on big data and the techniques used to study big data, in particular analytics and predictive modeling. Analytics is a business word. Predictive modeling, for the most part, are algorithms. You may have heard the word predictive analytics, which is a combination of these two. Aren't all models predictive? Well, actually, there are descriptive models and there are predictive models. Descriptive models, they begin with assumptions. You get a model, and you collect some data, you estimate parameters, and then you make predictions from the models. Predictive models, on the other hand, begin with these very large, complex data sets. And you have a question. In order to answer that question, you apply algorithms, and then you assess the results. Now, the reason for predictive models is big data. Modern data sets are very large, very complex. They're also very good. Unfortunately, descriptive models are not good at extracting information from such big data sets. So we tend to use predictive models, algorithms. And these algorithms are used in a number of different ways, as you can see here. So what is the predictive modeling approach? You start with a set of big data. You explore and see what the data is like. Often there's a pre-processing step where you transform the data and perhaps you rescale it. Now, once you are at this point, you go to the data mining allegory. The data mining allegories where you want to separate valuable information from the rest of the data, and then you want to assess the results. For example, small social networks like these are constructed from Facebook and Twitter and things like that. A natural question might be to suggest a new friend or a new product to somebody in the network. And as you can see, it's highly connected, and that high connectivity can be used to suggest other connections. Another example is genomic data. This is the first 100 rows out of about 20,000 in a set of data. And this set of data was collected from a number of different experiments. The experiments resulted in different expression levels, and these expression levels, which you can see with the colors there, are used to rank genes with statistical measures, measuring how well those things were ranked. Now, the focus is always on big data. You think of big data in the data mining allegory as the ore, and a few valuable nuggets of information embedded within it. But these tend to be very hard to find. Therefore, we use these algorithms to search for the gold, to search for the nuggets. Now, a good example of this are what are called classifiers. So you can think of panning for gold as being gold is class 1 and all the rest is class 0. And your goal is to find class 1, which is the gold. Now, there is a large theory behind this, and that is that big data is large. In particular, it's extremely large. And it's large because it's also very complex. That means that there are unpredictable processes mixed in with regular processes. A complex system is a large mixture of regular predictable processes and nonlinear unpredictable ones. This course looks at the concepts and ideas used to study the data produced by these systems. So in this course we have a couple of goals. Our first goal is to introduce the methods considered data mining and predictive modeling. Our second goal is to explore what it means for a data set to be complex. The background required for this course is mathematical maturity. I'll assume that you know calculus and linear algebra, and all the other math will develop in-house. However, we'll be using calculus and linear algebra in very mature ways. So you see a sample calculus problem here, finding a global minimum. The linear algebra problem, in fact, is not a vector space. The other thing that we'll need is willingness to work with a computer. We're not going to be writing programs per se. What we are going to be doing is looking at notebooks that already contain programs, and there'll be documentation of how to use those programs within those notebooks. These are going to be in the computer language Python. During the first 2 weeks, we'll learn the basics of Python and PyLab. We'll be modifying Python programs that I'll be handing out through the semester. Each week, we're going to have a specific theme. There'll be a folder for that week, and the title will be given for that. There'll be 3 or 4 short videos, some lecture notes, and some readings, and also an associated IPython notebook. There'll also be additional support materials on the course site. Most importantly, to get started, set up an account at www.wakari.io. So you'll have to create an account, but once you've created an account, then you'll simply be logging in. So I'll put my login information here and log in. And this is the Wakari Python environment. You can see there's a set of tabs. There are some things up top. There's a file browser over on the far left. We just hit it. Let's bring it back. The file browser has all your files, and it has pretty standard options for working with files. So we won't dwell on these. It's pretty straightforward what you do with these things. There's also a menu inside the notebooks. So there are file operations and edit operations and view, insert, cell operations. We'll look at a couple of those in a minute. The kernel operations, and also shortcuts. The shortcuts are a pretty nice addition. If you want to execute some Python code, you can run it from the cell menu, and it produces an output. So notice you've got a cell marked by N, and it produces an output. The shortcut for this is what's called Shift-Enter. If you hold the Shift key down and press Enter, then it will execute the cell. And notice that before a cell is executed, it's got an empty space in the brackets, but after it's executed, it tells you that it's already run. Now let's close the file browser, and let's look at the notebook gallery. These are free notebooks that you can use in addition to the things I give you in the course. So you might want to start looking at this one, Introduction to Python Programming. We can clone it inside of our notebook environment. And once we do that, you'll see that, well, first let's get rid of the files that's over there. So you'll see that a lot of the output is already there. Let's get rid of it. So we hit clear, and the output is now gone. But I would suggest going down to where it says Import Math and start the tutorial there. We won't need the things above, and this will be an easier way to get started.